For those that don't know or who haven't dialed into this show yet, I'm Ian Pilon, and I run AI Agents Global Media, which is a podcast where we talk to people building agents. We ran the world's first agent to agent payments hackathon here in Waterloo, Ontario, which was a 24-hour hackathon and exploring the bleeding edge of what people are doing with agents. I'm an author on a book on contextual intelligence and framed in the around product design. So how do we use context to build meaningful products? So I came across Andy on Twitter, and I will do a screen share of this because give people context about the first time I came across you. And this was the post that says the first fully AI generated scientific discovery to pass the highest level of peer review, the main track of an A conference ACL 2025. Zochi, I don't know if I'm pronouncing that right, is the first PhD
That's
level
Zochi.
agent. Sorry, Andy, is that not pronounced right?
No, that's Zochi.
Zochi. Okay, cool. So that's how I discovered you. Andy Cho, can you please just give us a rundown who you are, what you're doing, and help the audience understand a little bit more about you?
Yeah, of course. Yeah, I'm Andy. I'm the co-founder of Intology. We are a startup that just announced publicly doing mostly research and products around AI artificial scientists, which are a class of AI systems we're designed to do autonomous innovation and R&D in an end-to-end fashion. And yeah, we just announced very recently that our system was able to publish a paper in an A-star conference, which compared to some other systems, including our own, that we're able to publish in workshops a few months ago, is a much higher bar that we were actually the first to be able to clear. So that's pretty exciting. And then, yeah, on a more personal note, I was a student at UIUC until very recently. I just graduated, started mostly working on ontology. I was going to do my PhD, but then decided to drop out, just focus on this since I thought it was a pretty exciting opportunity. And yeah, happy to tell you all about what we're doing and how it started.
Awesome. Yeah, it's really exciting to have you on. You're doing groundbreaking work, and congratulations, by the way. So the one thing when I watched your video that jumped out at me was it's the first non-human made discovery to pass the highest bar of scientific work. Now, for those of the people that may not be aware of PhDs and academic bars, can you help it just bring it down to the general layman so that they can understand what that means?
Yeah, of course. So for context, I guess for even my own personal background, I've only published in an A-star conference a few times myself. The first time I did so was actually during my undergrad. The particular project took me more than a year to finish, and it took actually multiple review cycles until it got in. And then this is a pretty common experience for everyone, where usually, even for PhDs, it usually takes a few years before they're actually able to publish at like a venue like this. Most PhDs only publish maybe like 3 times a year in their entire PhDs, and that's kind of the bar to actually be like a PhD level agent or like a PhD have the level of expertise to have a PhD. So the reason why we're calling a Zochi a PhD level agent is that it's actually the first AI system able to publish in the same type of venue, and it's a venue that is just has extremely hard requirements on the quality and novelty of the work. So basically, the work actually needs to outperform every other work in this area in that problem space for it to actually be deemed as valuable. Um, and there's also like very hard review requirements to actually for both ascertain that novelty and also to make sure the results are valid and that people like the problem, find it valuable, and then people would actually care about reading the work and referencing it and building upon it for future work.
Okay, excellent. So then, so then you would know this process in a traditional sense because you were trying to get your PhD, and since you know that flow, for lack of a better way to describe it, even though that it's a longer term horizon, since you know that process inside out, is I'm assuming then that's what you were able to use as the inputs to shape how an agent can I don't even want to say reason, but she can go through a methodology to be as rigorous as what a PhD means. Is that a can you
Yeah, of
yeah?
course. Yeah, so I did a lot of training on science, so I'm very familiar with the scientific method, and that's really the core functionality behind our system is that it's executing a scientific method. And I actually touched upon an interesting point there that it's not just reasoning. Like most, when you even if you look at the smartest reasoning models, they're not really capable of generalizing out a distribution yet. We haven't really having these creative open-ended outputs, but we're actually able to embed it into our system just by forcing it or designing it to build out the scientific method, which is the same process that humans actually use to acquire new knowledge and it operating its open-ended spaces. So by doing that, our system is actually able to, even if it's still majority based on LLMs, it's
Yeah.
capable of actually proposing new ideas and even testing them and validating them with real experiments to know if it worked or not. And then if it does work, that ends up becoming a new piece of knowledge that even if it's impressive that we were able to publish it, but by itself, it's impressive that our system was able to come up with new knowledge and really advance the frontiers of human knowledge.
Yeah, yeah, and it's so when you say the scientific process, it's hyper rigorous, and we're not talking about applied research. We're talking about rigorous science. So when you say that it's come up with new knowledge, maybe help the audience understand the difference between that being rigorous versus LLMs for the general layman might be seeing things like hallucinations, so they don't quite trust these systems. How would you describe or help anybody else in the audience understand how yours can be much more rigorous about coming up with new novelty compared to just an LLM that potentially is hallucinating or something?
Yeah, of course. So the main reason is that it is executing the scientific method, which is the tool that humans have used for centuries to validate their own hypotheses. So I guess in the context of what we're describing from AI scientists, the outputs even are just hypotheses. So it could definitely most of them are actually false and have a lot of issues, but it's able to take those hypotheses, write out code, and validate them for real experiments. And we have ways in our system to verify that the code is correct and that the actual downstream data sets it's evaluated on couldn't be hacked. So basically, for example, like people are very familiar with now in like AI spaces where LLMs are tested on these benchmarks like MLU or SWE bench, right? So we basically are able to use the similar protocol for the experiments and ideas our science is generating to validate if those ideas are correct or not. And then because we have that golden validation signal,
Mm-hmm.
if it's actually higher performing than human designed methods in this space at that point, we can be very confident that the ideas that we came up with were actually
Wow.
valuable. And that ended up being the signal that even human reviewers used during our peer review process for the papers it was able to publish in these scientific venues.
Very, very cool. Because I get the scientific method, right? So you're going to go through, you've got these assumptions and you generate the hypothesis before you go do your work so that you can be rigorous and not have confirmation bias and look for the information you want to find. So are you saying that you started the process sort of with some hypothesis in the beginning, and then when this thing started working in the rigorous method, that because usually when your findings happen, you're able to re-evaluate your hypothesis and then start a new experiment based on your findings. Is that where the agent was able to start generating its own hypothesis after you had already given it something to jump off from?
Yeah, so I guess at a high level, so for the papers we submitted, it was actually fully autonomous.
Wow.
So all the hypotheses were generated by our system. The only input given to it was just a domain of interest and a problem
Oh,
of interest.
cool. So
Yeah,
give me an example of that. Yeah.
yeah,
What was the first one that you were like, oh, this is really, really cool?
yeah. So our paper our ACL paper, it was on jailbreaking. So this is an area where the system is essentially trying to identify new methods and algorithms for discovering security vulnerabilities in other systems. And this was just an area we picked because I was pretty familiar with it, so I can like tell at the end that if the paper was good or not. But yeah, it was essentially gave it the domain of jailbreaking, and then from that input, it was able to analyze all the relevant literature and papers in this area, come up with its own hypotheses of how to improve existing jailbreaking methods, how to develop new ones, how to like tackle new vulnerabilities that nobody has tackled before, and even like methods on how to defend against it. And then so the initial set of hypotheses was very large, and it was able to these are both hypotheses and ideas for actually that could be turned into a paper. and it was able to essentially autonomously implement all of these methods and test them against a downstream benchmark, the same way human scientists would in this problem space.
So
And then
cool.
eventually, through a process of refinement and iteration and evolution, and pairing all these different methods and identifying like what works and what doesn't work, it was able to eventually find a method that ended up working very well and is actually currently the best jailbreaking method to my knowledge. And that ended up being the algorithm we published. We submitted as a workday, so that was ended up getting accepted.
That's amazing.
Yeah.
That's
So
awesome.
that's kind of like the high level process of how it works.
Okay.
Uh,
And then so you started on that domain because you already had familiarity with it, so then you could sort of have some intuition about whether its results were like on the mark or off the mark. Was there any other ones, any other domain spaces that you started to experiment with right after that one?
Yeah, so this was actually the paper was actually a version, or it was an updated version of another work we did. We submitted to iClear workshops a few months before that, and yeah, and then at that initial launch, we had papers generated in multiple domains. So besides jailbreaking, we also had papers in computational biology. It was able to discover a new architecture for, I think it was a protein binding site prediction task that was more efficient. But this was like an area that I actually didn't know very much about. So we had to actually go to professors and had them verify the results
Wow.
and know if it was good or not. But yeah, it shows that like it works for. There's a lot of like cases where scientists, users have domains of interest or problems that they care about, but they don't really have like the expertise to do that themselves. I think it's a cool example of like where people could use Zochi and have our system kind of explore different areas they wouldn't normally get to explore.
Yeah.
And then the other paper that was accepted was a work on fine tuning LLMs. So here it was able to discover a fine-tuning algorithm similar to LoRa to adapt LLMs to new domains on limited data that was both more efficient and more effective than LoRa, which is the most common algorithm people use.
Okay, this is amazing. So then for Zochi, and then in the biological context, is can this be applied to a business context as well, or is it more of like on the academia side? Like, so if do could a company that's trying to think about strategies, could they use something is like this, like Zochi, or is that overkill?
Yeah, yeah, of course. That's actually the enterprise use case, something that we've actually been thinking a lot about, just because we're also building a company. But at the core, at the end of the day, like I think even at a higher level, Zochi is just a system that's capable of solving these open-ended problems. We're given an objective,
Yeah,
it's able to find a solution. So if you compare Zochi to like something like a normal or like a more common agent, like maybe a Devon, or for example, most of these current agents have a I would say are a little bit more limited in the sense where they can only really execute tasks given to them that are kind of more short horizon and narrowly scoped,
yeah,
solving a GitHub issue or
yeah.
submitting a PR. Wow, we by forcing by just kind of by necessity of needing to do autonomous R&D, we've actually built an agentic system capable of doing more open-ended challenges.
Wow.
So the
Yeah,
input to our system is not a task; it's more of a
yeah.
strategic objective or a goal,
That's
and it's
that's
able to break that down into tasks and
Yeah,
so.
that's super cool because I talk about this in my book where that time horizon is critical because in my experience in UX work for a long time, there's a heavy focus on the interaction design in the actual interfaces, but the more that I see where the future is going with agents, I can get these things running long term and cycle through longer term goals. So yeah, I could totally see how you're going beyond limited use cases and going, well, if this thing can hold context, has memory, it can keep going deeper on challenges and problems. So is that what is? Do you have a memory framework as part of Zochi, or do you hook into other partners for that, or is it all built into Zochi?
Yeah, yeah, that's very interesting. Yeah, we definitely have a memory component. So our system is actually capable of operating autonomously for even several days sometimes.
Wow.
So this is
Wow, that's
it's a long
awesome.
time, but like if you think about like the process it takes to make a scientific discovery, that usually takes months.
Yeah,
So that's we're already shortened that to a process that just is a lot faster, just because our system's capable of autonomously generating that code and running it purely computationally. Yeah, memory is a huge part of it. We need for any particular problem it's working on. The memory is storing things like failed trials.
yeah,
Most of it is just failed trials, but it's able to use memory to learn from that and actually improve the method until something works.
very, very cool.
And
Keep going.
yeah, I
Sorry.
guess like in general, like even the scientific method, like people use it every day, even in their own lives. And if even for businesses, like there's a lot of situations where they just have a code base that hasn't been updated in a very long time. They care about getting that performance up or maybe making it more efficient. And then that's like a situation where Zochi can just our system can just work with that code base, make the necessary improvements and refine it. And then since we have like metrics to compare it against, if those metrics we know go up or down, that contribution ends up becoming very valuable in that context.
Yep, yep. This is brilliant. And then, so up to a couple days, if I play back is what Zochi's capable of, which is outstanding. Um, and then, am I able to look inside of its process? So if I want to go back and say, well, it come up with some new hypothesis, how did it come up with that? I know that's a lot of thing everybody wants to know. I want to look inside of how it came up with its determinations. Is that easy for an enterprise to sort of look in behind the hood and see how it came up with its novelty?
Yeah, of course. So yeah, part of it is that it is operating for so long, but we don't really expect people to, just give it a problem and then check in a few days later
Okay.
after it like burn through a lot of resources, right? So our so the reason why our papers are fully autonomous is just because that was the hardest setting to really prove out the capabilities of our system and its
Oh, okay.
hardest use case. But then for actual platform, it's going to be a lot of our design is just based on where to give human oversight, where can humans look and monitor these agents as they operate over these long time horizons. And yeah, we designed our platform to really be able to support this. Similar, the design hypothesis is that we kind of want the interface to kind of be like how a professor interacts with their PhD student, like how a project manager interacts with their employees, where they're people unlike things like cursor, for something like this, since it's just not possible to look at all the lines of code being written, we really want to move the oversight kind of to a higher level where it's not just looking at every line of code written, but more so looking at the results of individual experiments and individual hypotheses generated by our system. So we're able to design a way to kind of easily monitor that and give like high level oversight and feedback at critical points to be able to steer the agent towards certain directions and that are fruitful or give it like certain constraints like I want to use this data set, can you test on this
Yeah.
model, etc.
Yeah. So cool. It's already making me think of a couple of relationships that I have that'll most likely want to potentially play with this and try it out. Is there, and then, so obviously the land grab early is with code. But then you mentioned you're already thinking about enterprise plays. Is there any particular vertical or healthcare? Is there any particular customer that you would love to work with?
Yeah, so our system works very well in situations where it's very easy and to actually evaluate if a method works or not, which also makes so the core issue currently with these systems in general is that it's very easy for them to hack evaluations,
Mm-hmm.
and if it ever gets to the point where you don't trust if the evaluation is correct or not, or the method is valid or not, then the entire thing becomes useless.
Mm-hmm.
So we really want to focus on these domains where it's very easy to validate if a method works or not, and that makes it very hard to hack against it because we can just ensure that the system can never touch that evaluation pipeline when it's once designed. So we're for Enterpace, we're really focused on kind of looking for these customers that already have metrics that they use to validate their own systems. So mostly like ML teams, like recommendation systems teams, or in a lot of areas, or like credit loss prediction and banking are all areas that I think will be very good to deploy Zochi in. And then even kind of more on the horizon here, I do see this necessity of having this validation as a limitation, just because uh, real science is even more open-ended, and a lot of scientific domains don't really have this automatic validation that machine learning has. So in order for us to fully deploy our system in wet labs and natural domains like chemistry and biology, we do need to solve this problem, and that's something that we're very actively thinking about.
Okay, very cool. Um, all right, we've got about 5 minutes left, so let me pivot into something a little bit different. So I think your research has been implemented into some of the bigger frameworks like LangChain, AutoGen, Llama Index. For the developers listening, how are those tools enabling the creation of more sophisticated agents? And what are the current limitations that you're still trying to push past?
Yeah, yeah. I did some earlier research in my when I was undergrad that was implemented to Llama Index and LangChain. It was a framework that uses search with
Okay.
agents to be able to enhance decision making. That actually is part of is using Zochi. But yeah, I think for these tools in general, I think at least for us, we actually directly just use the frameworks provided by the Foundation Lab API providers like OpenAI and Anthropic. And so we don't actually use LangChain very much. I heard that I think it's good for testing like a simpler systems, but I think at the end of the day, it's better to have kind of more customizability and control over your code and how it interacts with the base model at like a more granular level. I think that's just a matter of taste. Yeah, I'm interested in how other people use these tools.
Okay. All right. Cool. Are you getting feedback from other people using your tool right now? Is that
Oh yeah,
yeah?
so we actually, along with the ACL paper announcement, so we announced that we're starting a public beta. So for our beta, it's a kind of a more lightweight version of our system where it's not doing the full end-to-end
Okay.
experimentation. Yeah, it's just doing the hypothesis generation. So it's designed to be more of like a co-scientist or a colleague, where if a researcher or user has different ideas they want to kind of discuss for a system at like an extra level, it's able to do that. And then like as we test the experimentation in more domains, we'll also be rolling that out as part of of the beta. So right now we just have a very small limited set of users. We're obviously we're happy to talk to more and keep start some relationships.
Okay. Cool.
Fully deploy our system that's fully ready.
Cool. Because I think that's what this podcast helps do, right? I love to hear the stories about why people are building what they're building around agentic systems, but it's an opportunity that we get your story out there, so we can definitely try to once post production is done is and share this is to sort of target and try to get your story in front of people that actually might find value in this. So okay, the grand vision. If Intology is wildly successful 5 years from now, what kind of scientific or research breakthroughs do you hope will be enabled by this technology? What fields are you most excited to impact?
Yeah, I think the ultimate vision is that we're able to build a scientist that can work in pretty much any domain or any field, just because the scientific method is agnostic, and these base models already have so much knowledge of all these domains that it definitely seems feasible for me that we can have one scientist that is an expert in every domain and can use all this knowledge that it knows and even knowledge that it's able to discover on its own to impact its research in all these areas. I think that really the next big challenge is going from a paper that was just accepted into a core breakthrough that has even eluded human scientists, and maybe some would say is kind of outside the scope of like what humans could possibly do. I think that's really the core motivation point building something like this. Like, I'm not trying to take away jobs from scientists. I'm just trying to be able to create systems that are able to do things that can either augment human scientists or like even do things that they're not able to do. For instance, there's a lot of work that maybe like just requires so much experimentation that nobody really wants to tackle. And I think those are the areas where we are the most promising for AI scientists to
I
tackle.
love it. I love it, Andy. That's the right way to go. How can we enhance the human experience, not displace it. I think there's so many people going in that direction. It's just, that's not
Yeah.
exciting to me. I love the work you're doing, Andy, and I want to help you succeed. So I will, and I have a bunch of relationships. I can connect them to you. But as we're winding down here, there's an opportunity for you to share any other call to actions. Do you want people to follow you on X or Intology? What do you want to leave people with?
Oh yeah, feel free to follow me on Twitter or our Intology page. If you're interested in using Zochi, sign up for the beta. We'll be rolling that out very soon.
All right, cool, Andy, and I'll add those links in once I'm done the post production. So, thank you so much for joining the show. It was such a pleasure to have you on. Thank you.
Yeah, thank you. Thanks for having me. It's great.
Awesome.